Hi, everybody. Thank you so much for coming today. My talk is an ActiveRecord rewrite, the story behind the Attributes API. My name is Tess. Today, we have a story about refactoring a large part of ActiveRecord to make it more stable. First, we'll have this user class. This is its table. It has an attribute ID whose type is integer. Now we'll have an instance of user. We are setting its attribute to the string 1. Now let's call ID on the instance of user and see what's returned. You might expect that calling it again would return the same thing, the string 1. We just set it to be a string. But we get back an integer. Its previous type, string, was cast to integer. This is typecasting, turning the data from one type to another and vice versa. When we look back at our table, we can see that the type for the attribute ID is integer. That's why when we pass it the string, Rails cast its type to an integer. Now, how does Rails handle typecasting? In Rails, the Attributes API handles typecasting. In Rails today, the Attributes API has been extracted to Active Model, but it started off in ActiveRecord. For today's dive into the Attributes API, I sat down for a conversation with its author, Sage. Well, they're actually here, and they're not a plant, so Sage Griffin is my wife, and during the early years of our marriage, they got into open source contributing and refactored so much of ActiveRecord that I wanted to talk about it. For context, this was like 10 years ago, took place in general between 2014 and 2016. The major internals refactoring was in Rails 4.2, and then the public API was released in Rails 5. So my first question to Sage was, how would you describe the Attributes API? And they said, it's the code that does the types. Okay, pretty straightforward. And then I asked them, well, what is typecasting? And they said, when ActiveRecord receives your data, it's almost certainly going to be as a string. You as the developer don't want a string. You want an integer or date or whatever useful Ruby object that data is representing. The Attributes API and ActiveRecord will deal with converting from your Ruby objects to those string representations and vice versa. So I asked them, where did the inspiration come from? And they said, well, we were on a project and had an attribute that needed to be encrypted. We wanted it to be that whenever you accessed it, you got the decrypted version and vice versa. We were using a gem, and I looked at the gem's code to see how it was doing that. The gem was pretty buggy, but I discovered that looking at the code, how much of the Rails internals it had to monkey patch to do this work. And that's not the gem's fault. The gem had to monkey patch all of these different code paths. These are Rails internals, so they are undocumented and interact in subtle ways. This is very difficult to get right. Supporting multiple versions of Rails for gem authors becomes difficult or impossible when you're monkey patching internals that aren't stable. It's like building on top of shifting stand. Because they are internal, they can change without deprecation warnings in between versions. Sage said, I thought that there had to be a better way. I said that they sounded like an infomercial. They said, yes, exactly. I was the person in Grayscale doing things the old hard way. I was the person who had to, this is a person cutting up bread with a doorstop. And yeah, infomercial commercials are weird. There had to be a better way. Rails should make writing this gem easier. Gem authors shouldn't have to monkey patch all of these undocumented Rails internals to get typecasting of encrypted attributes to work. So how did typecasting work before? Sage said, well, poorly. This is our example of typecasting, taking the string 1 and casting it to the integer 1. Typecasting has 3 general areas of work that it does: writing, reading, and saving. To show how ActiveRecord handled typecasting before Sage's refactor, we're going to try to follow the code path for writing the ID attribute. It's going to be totally fine. Trust me. Okay, so don't mind the module counter here. We're starting off in write_rb, our first module. Write_rb takes the attribute name and then the value, which would be the ID and the string one. Oh wait, hang on, sorry. Our write attribute gets overwritten immediately in a different module, dirty. So in dirty_rb, our second module, we have write attribute again. We do some things, call super, cool. So that takes us back to write_rb. Now we have to resolve typecast attribute for write. Okay, let's see its definition. Oh wait, sorry, hang on. Typecast attribute for write also gets overwritten in a separate module, serialization. So this is just, we're running through 3 different modules, and we go back to write again, and then just, yeah, no, this is, it's not great. To be clear, we're not even close to being done with writing yet, and we've already gone through 3 different modules. This is what debugging in 4.1 felt like when trying to debug this typecasting behavior. So these are just all of the modules that could possibly contain overrides and methods we're working with. The logic was so spread out in these modules, the behavior leaked everywhere. It was way too much to hold in your head. Sage said, which of the 6 places that define the same method is the one that actually has the bug? These methods were a nightmare to deal with. Sage said that they were all sort of ad hoc and spread across the modules. You would have like 6 different modules all define the same method. It was spaghetti code if each noodle was a module and they're all lumped together. Eventually, you resolved to 2 hashes, before typecast and after typecast. You can see that in the before typecast hash, the key is the string one. Sage really wanted me to let you know that the keys are strings. That's very important, apparently. And the value is the string one. And then after typecast, it's the integer one. So it boiled down to just 2 hashes, but the road to get there was pretty hard to parse. This is Sage's first pull request to Rails in the spring of 2014. There were 37 files changed. Their intention was to just refactor typecasting behavior. The problem was another person was already doing this work in ActiveRecord. This is what it felt like to review. Just a bit overwhelming. The maintainer of ActiveRecord wrote, please don't add more stuff to this PR. Please don't. Sage was only trying to refactor how typecasting worked in ActiveRecord, but like how we talked about earlier, its behavior leaked everywhere. This first pull request was way too big and way too complex. Soon after, Sage was invited to Basecamp, where the maintainers of Rails chatted about working on the project. Sage worked through that summer in 2014 and into the fall, making small refactor after small refactor. And I asked Sage what was their North Star. What were they trying to refactor all this leaky code into? And they said that they were refactoring to something that managed state internally in a way that you would expect in Ruby. This means that instead of code spread out all over the place, they wanted objects, instance variables, and methods that encapsulated the behavior. So remember our user example. In the refactor, you have the new attribute object and new type objects. You can see here in from user, we're taking the value, which is the string 1, and this new type object, the type, active model type integer. The attribute object holds the state, and then it asks the type object given to it how to do the conversion to and from its type. Put simply, the spaghetti code got put into a box, the box being the attribute object. The attribute object can now ask, hey, datetime, turn my string into one of you. These type objects now hold the logic for casting, and the attribute object delegates to them. Debugging went from digging through spaghetti to, oh, we probably just used the wrong type object. Cool. Sage said that the code got re-architected into this more generic way. Entire classes of bugs became just impossible. So for example, this one relatively small PR just closed all of these issues just by itself from this one refactor. In another example of bug fixing, Sage mentions how this feature just works now. So if you were upgrading your Rails project from 4.1 to 4.2 or the beta for 5.0, you might have just started having things work now. You didn't even know were broken. I asked Sage, what do you think was the hardest trade-off you had to make in this refactor? Initially, making the code maintainable came at a performance cost. So I previously mentioned how the initial code resolved 2 hashes. The work and memory of allocating 2 hashes is computationally small. Depending on how many records you are reading from the database, these allocations can add up pretty quickly when you're allocating Ruby objects instead of just 2 hashes. Allocating a lot of Ruby objects is objectively going to do more work than 2 hashes. So how many are we talking about? So it's 1 attribute per column per record. In the real world, your user table is going to have a lot more than 1 attribute. So let's say we have a users table and we have an admin page and we're displaying 20 users. And let's say you as a developer are making a query and you're showing 3 attributes, but maybe you don't select just those 3. ActiveRecord will grab all of them. Our user has 40 columns. So 20 users times 40 columns is 800 Ruby allocations, which is objectively a lot more than 2 hashes. Multiply this by all of the different records you're having to query for, this adds up quickly. So one of the low-hanging fruits for performance gains was instead of allocating all the objects, changing the code to only instantiating the objects as needed. For example, this would reduce our example from 800 Ruby allocations to 60, which is a lot better. This is that PR. Sage said that I remember spending several weeks just working on performance, and we clawed it back to the point where they don't think that 4.2 had significant performance regressions. And they said working on open source projects was hard because Rails is dependent on by a lot of different users. And it's tricky because there are various benchmarks that they can run, but every application is going to be different. So covering all of those is really hard. And so I'm pretty sure at one of the RailsConfs before this was released, they had the beta out and Sages were literally running around everybody, please try the beta. I will pair with you if your app gets slower. And they ended up pairing with a lot of people. I asked Sage for their thoughts on the importance of maintainability. They said that I'm of the opinion that if the code is buggy and unmaintainable, it doesn't matter how performant it is. If you're doing the wrong thing fast, you're still doing the wrong thing. Code that is hard to follow will attract more bugs. When you make the code easy to reason about, you make it more stable. In open source projects, you have a lot of hands touching the project. And the more hands, the more bugs it will attract. So in general, said you should try to leave the code better than how you found it for yourself and for other people. And other people includes you 6 months from now when you have when you do get blame and you're like, who wrote this? Oh, it was me. I'm the problem, it's me. Sage is a big proponent of commit messages as documentation. Sage did this a lot by making their commit messages have all of the context that they were thinking of at the time that they wrote their pull requests. This isn't an example of that. This is way too large to fit on a screen, but famously they had a code change that was 2 lines, and it was like 19 paragraphs. So the ratio of context did not always meet the code, but writing a talk like this was really only possible given past Sage's context at the time they left behind as breadcrumbs. Finally, I asked Sage for their thoughts about contributing to open source projects. Ones like, especially like Rails, but they had contributed to other open source projects such as crates.io. For context, Sage contributed a ton to Rails over the years that this refactor took place. I took the screenshot recently, and even though they haven't contributed in a while, they're still number 15 of all time. So I'm pretty proud of that for them. So stability is essential, especially for open source projects that a lot of people use. You don't want upgrading Rails versions to be painful. I think we've heard quite a few people at this talk, looking back on Rails, mentioning how painful it was to upgrade projects from 2 to 3. And around the time 5 came out, the core team started taking stability much more seriously than previous versions. If your public APIs aren't stable and upgrading is painful, people tend to stay on the old versions. Open source maintainers want people to upgrade. If there's an important security fix, you don't want to have to go back to older versions and fix it when you've already fixed it in the current version. And then I asked Sage, did they have any tips for how to be a helpful contributor? And they said, please don't just put an open issue into Claude and then just open a PR with the results. It's gonna get closed, I'm sorry. Please read the contribution guide. They've written it for a reason, and they're usually pretty great to help you get started. Contribute how the project would like you to contribute, because oftentimes contributing to open source can be things like triaging issues and reproducing issues. People working on open source projects are just people, so it's really good to just talk to them if you're interested. Don't be like Sage. Don't come out of nowhere with a giant pull request and expect it to be merged, because it probably won't. Thank you, Ruby. Write code that's meant to be read by another human, because it will be right now. Shout out to our friends project, Code Triage. You can sign up for it, pick some open source projects, and it will send you issues that are beginner friendly to work on if you want to get started contributing to open source. So I asked Sage if they had any final thoughts, and they said that they think the most impactful work was refactoring ActiveRecord to make it easier to use. And they spent years of their life working on this, and I think it's really cool to be able to celebrate that and making the code more maintainable at the last RailsConf. So I'm currently at ThoughtBot. You can find me, Tess at Tess.ThoughtBot. I just want to thank them for letting me come here today and talk about this. It feels full circle, because when Sage actually worked on this, they actually worked at ThoughtBot, and they used ThoughtBot's open source, their investment time to actually do this rewrite. And so it feels really special. So thank you, everybody.